Welcome to solverfy.
Okay, so for this question, we're looking at a 5 nanometer wavelength photon, and we want to work out what the energy of this photon will be. So simply, we're going to look at Planck's relation here, which is that E is equal to hc over lambda, where E is the energy of the photon, h is Planck's constant, c is the speed of light, and lambda is the wavelength of the photon. Now this formula, the dimensions, will give you an answer in joules, and the question wants it in electron volts. So we're going to use this relation here. 1 electron volt is 1.6 times 10 to the minus 19 joules to convert it. So we find that E in joules, if we throw in 5 nanometers, we get this is 3.978 times 10 to the minus 17 joules. And to get this in electron volts again, we just divide by the 1.6 times 10 to the negative 19. And for this, we get it as 248 electron volts. Now for part B of this question, it's a bit more tricky. We got to use the de Broglie wavelength formula, which is h over the momentum. And you should know that P is also equal to mv. And because we're interested in the kinetic energy, we can use that E is equal to a half mv squared, where m is the mass of the particle and v is the velocity, and then rearrange this to solve for B. So we get that v is equal to root 2e over m. Now, if we put this into P and then put this into lambda, we end up with lambda is equal to h over root 2 me. And then we need to find what E is. So now we just rearrange this equation here for E, where we get E is equal to h squared over 2m lambda squared. Now, as before, this will give a result in joules of around about 9.65 times 10 to the minus 21. And then we just use the exact same relation as before by dividing by 1.6 times 10 to the negative 19 to get this answer in electron volts. And we simply get it as 0.06 electron volts.